Okay, let's see. Okay. Um, I'm sure to much of your surprise that I am not here today. However, I'm sure you are also very happy. And if that's the case, well, I don't like you anyway. But the fact of the matter is, I am not here today. So instead of having a traditional lesson, we are going to have an online lesson. You're going to watch this video, or if you don't want to watch the video, perfectly fine too. A lot of the information is already written down for you, and I think you can understand at least a little bit of what I've written. So that's kind of your choices there. Either you watch the video or you don't watch the video and you just go through the notes. Okay. But nonetheless, whatever the case may be, you are still completing the notes, as it were. Okay. So we're talking about volume and surface area today, which is a very good topic to have to talk about because this is also just a really good real life situation kind of thing you would need to know, right? If you are trying to build a house, if you are trying to build a something, if you want to make a can of something, right? If you're going to be in some sort of manufacturing business or if you're going to be in some sort of building business, these are all very good things to know. Uh, so we'll get into it. So if you haven't done so already, go ahead and do your do first because, do first is a good idea. You should do that. But I'm just going to assume that you've already done it. And so if that's the case, you can just move on right ahead. I will go ahead and write the answers in. And here we go. The first answer for this rectangle you should have gotten is 32 inches squared. Okay. Don't forget your square because this is about area. So inches squared. Then for the circle, you should have gotten 78.54 centimeters squared. I did round to the second decimal place, otherwise known as the hundredths place. That's probably about where I would want you to round for right now. Then for our triangle here, we should have gotten 14 meters squared. Easy enough. And then our last rectangle here, 640 meters squared. You should not have really any issues with these. If you do, you really need to reevaluate some of your things, some of the methodology you just are using and whatnot, because we do have the reference sheet right there, or at least the necessary reference sheet right there. So go ahead and do that if you did not do it already. Here are different vocabulary terms. I know there's a lot, but there's just so much in this kind of unit here that is really important. And actually, this is supposed to be split across 2 days. And just because of the way that everything just worked out, I think that this was just the better time to do it. We weren't supposed to do this until like 2 weeks from now or something like that. So I found that it was probably the most appropriate to fit this in right here whenever I know I'm going to be gone, rather than have you try to start something and then have me need to reteach it to you the next day. Because the next couple of topics, they build off of each other. And so if you can't learn the first topic, you can't really learn the second or third topic. So it doesn't really make any sense. But here are vocabulary terms. Solid, it's a three-dimensional object, pretty cut and dry, pretty simple. Our surface area, SA, is the abbreviation. The total area covering the surface of a solid. Volume, V, the amount of space inside of a solid. Base of a solid is the shape of the bottom and top of the solid. More about that later on. Base area, capital B, is the area of the base of a solid. Lateral area, the area of the sides, not including the bases. More on that later. Cubic units, the unit of measurement for volume. And then the last one here is perimeter of the base, capital P, the perimeter of the base of a solid. Okay, a lot of this we will get into later on. The first thing we're going to talk about first, though, is our prisms here. Prisms are polyhedrons is the more technical term for it, but you don't need to know all that. And you can read all that text. I'm going to kind of paraphrase here and there, and I might read a line or two, but basically whatever I say on the page or whatever I say right now is basically on the page because I made it all the notes. Shocker, right? Couldn't wait for the district to make the notes yet, because again, but technically about 2 weeks ahead of schedule. But so I made these notes about to the way I think it makes sense, especially since you don't have, a full unit of volume and surface area. You have to basically learn this in a day. Not that you can't do it, but we got to do it. We got to do what we got to do. But here We need to be able to identify a lot of the different kinds of faces that we can see on a prism. And the most important face is going to be our base, okay, B-A-S-E. So here, the base of a solid is and always will be whatever the shape is called, always, no matter what. Okay, so explained here, if I call it a triangular prism, it's going to be a triangular base. It's going to be. Okay, so whatever I call it, that is what's going to be. But you have some issue with, let's say, a rectangular prism, where it could be a little bit more difficult to decide what rectangular prism is, or which of the rectangles are the face of the rectangular prism. That can be a bit hard. However, the best way that we're going to be explaining it is think about it as if it were resting on a table. And the face that rests on the table, that is what we want to consider our base. Kind of like if you were to put your computer on the table, right? The bottom side of your computer is the quote unquote base of your computer. Same kind of idea there. So if I had to visualize this, given the image that we have here, the rectangle that I'm thinking of is my base is this rectangle right there. Okay. So that rectangle right there, where it includes the length and the width as part of that rectangle. It will also say that there is a direct opposite face from the base that is the exact same. So even though I circled this this bottom base here with purple, this red base is the exact same thing. So it has the exact same length, it has the exact same width, it has the exact same area, perimeter, everything. Everything is the exact same. The word I use is congruent because that is the more technical correct term. So if I'm saying something is equal or I think it's congruent, that means that they're the same thing. They are exactly the same thing to each other. So don't get that very twisted right now. And I kind of just, again, going over a couple things. The first topic we're going to talk about is volume and specifics with our prisms. But a couple little just small details that we need to add here is that a volume is measured in cubic units, and it looks like units to the power of 3. So very similar to how we had our area in units squared, volume is going to be in units cubed. Okay, so uh, don't make that small difference be too much of a bad thing. Just memorize that volume is 3, area is 2. Okay, anything like that. You may have heard of this in density in a science class. Maybe Mr. Floyd has talked about it. I don't know. But if you have seen density, it's a similar concept, but not quite the exact same. Okay. So for right now, you can kind of think of density. So our volume equation is just capital V equals capital B times H. Very simple. Very, very, very simple. Okay. So because it's so simple, you may think, well, why is this even a hard topic? Well, there are a couple things that make this kind of weird. Okay. So I should be able to first identify what my base is. My base, even though it doesn't clearly show it, is going to be this figure that would be kind of like right there, that rectangle that I would normally see right there. Or in other words, I can see it also on the top, right? Very simple. And because I have this 12 and this 5, that must be included into that rectangle, blah, 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 all that stuff, okay? But again, recognize that the base is whatever's on the bottom or whatever's on the top if you are trying to find the base of a figure. I will also kind of go back a little bit here. I do say find the volume of this prism and do not say what the prism is. Okay, sometimes you will have to decipher what the prism is first and identify what kind of prism it is in order for you to move on and actually solve it. Okay, so if it says find the volume of this prism and the base that you see is a triangle, that's obviously a triangular prism. You need to figure that out for your own sake, though. But we'll move on. The capital B represents the area of the base or the base area, whichever one you prefer. And all it is just finding whatever that base is, in this case, a rectangle, and finding the area of it. which again, you should already know how to do. Again, from right there. Now, we don't usually say base times height for rectangle. We more likely are going to say area equals the length times the width because it makes more sense to say length times width, but you may see it as base times height as well. But more on this height situation later on. And by later on, I mean like right now. So once that I find that my base is a rectangle, I multiply the two values that make sense. In this case, it's a 12 and a 5, just like the diagram shows. I will get some value for it. I don't need that value particularly right now. But the quote unquote H can be pretty confusing at first. So with any solid, no matter what the solid is, it will always be the height of that respective solid. Okay, so think of it as like a thought bubble right here. My height of the prism in the diagram that I hadn't seen before is this measurement right here, where 3 inches is the height of my prism. Okay, and there are two ways to think about this. Okay, the first of which is, well, how tall is my prism? Right, that's pretty self-explanatory. That's pretty easy as far as you can tell, especially if we have like a rectangular prism or a square prism. Just how tall is my shape in general? However, the thing that I think is going to make the most amount of sense is what is the height between my first base and my second base. So notice how I will label this as base 1, and I will label this as base 2. Whatever the height is between my base 1 and my base 2, or whatever the value is between my base 1 and my base 2, that's my height. That's always going to be my height. Okay. So if in the event that, let's say, you are looking at a triangular prism and you're like, I can't figure out what my height is, well, look for the two triangles and find a distance between those two triangles. Hint, hint, wink, wink. That's one of your problems later on. But the problem that I think a lot of us are going to see is that if we go back to our area equations right here, we see that we have a couple of different H's, right? We see an H right here, right here, right here. There's no other H's, but those three H's. Those three, that's the height of a 2D figure. Okay, so since it's the height of a 2D figure, that's the height of my triangle. That's the height of my trapezoid. That's the height of my rectangle or parallelogram. It is not the height of the prism. Okay, so the quote unquote height of prism does not equal the height of, let's say, like a base, for example. They are not the same thing. You cannot think of them as the same thing. So don't. Okay. All that to say is make sure you know what your H is. H is the height of the prism, unless you're looking at specifically the area of a specific shape. And therefore that height will be specifically to that shape, like a triangle, for example. And I explained it all here, blah, 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 all that stuff. Here is probably the biggest key thing here is really for any volume or surface area problem, you need to be able to identify the base. Okay, you need to be able to identify the base. Second thing you need to use is the volume equation to start identifying the parts that you need. I'm going to say volume and surface area. Okay, that's important too, volume and surface area. And then number 3 is to use Desmos to plug in all the parts. It's super easy, super simple. You should not have very many issues with it at all, really. A lot of this is going to be Desmos heavy. So I'll give you some time. Go ahead and try this problem. I'm not going to put any work on the actual screen itself. I will put the answer at the very end, but go ahead and try this. And then whenever you come back, whenever you're trying to find your answer, here's the answer. 144 centimeters cubed. Okay, again, cubed because it's a volume. When you've tried this one, go ahead and come back. You should have gotten a 55.76 inches cubed. Again, try the workout, put it on your paper, put it into Desmos, do whatever you think makes sense. Okay, do whatever you think makes sense. Follow the equation, right? This equation specifically right there. Follow the equation that we have right there. Okay, the area of my base, right? The first one is a triangle. So find the area of the triangle and then multiply by the height. Very, very simple. Okay. But let's say that you have some troubles. Okay. Because we can have troubles here and there. Makes sense. But let's say we have some troubles. Well, if again I recognize that my height here, sorry, my not my height, my base here is a triangle, I can go ahead and just solve it like I normally would. 1 divided by 2 times my height of 3, it shows me here. A height of 3 times my base of 8, it gives me 12. Well, there's my capital B. My lowercase h for my prism, my height of my prism is 12. There I go. I just plugged it all right in. Notice that 1/2 3 times 8, that's my capital B. 12 is my h here. Okay, so don't make it more confusing than it needs to be. Okay, so keep going. Again, especially with the prism is very easy. Don't get it too confused. Prism is a lot easier. Multiply the 3 values. Okay. So the prism is pretty easy for the most part. But the cylinders are only really slightly different. Not much more difficult or like easier. But I think it's kind of about the same. And it's also good in some ways and worse in other ways. But we know that since we're working with a cylinder, the capital B is always going to be a circle. It's always going to be a circle because, well, a cylinder doesn't exist without it being a circle. This is actually what we call a non-polyhedron, but again, you don't need to know that. Just something to add in there. But take, for example, this cylinder here. There are 2 pieces to the cylinder volume equation that are just like the prism. We need the capital B, we need the lowercase h, but instead of actually needing capital B times h, we're going to use this equation. Because again, we already know what the base is always going to be. With the prism, it's a little bit differently, where I could be working with a rectangle, I could be working with a square, I could be working with a triangle, or if you're getting into harder geometry, you could be working with a pentagon or a hexagon, heptagon, a nonagon, octagon, decagon, anything like that. You could be working with a ton of different kinds of shapes. So you have to have a general equation for it, capital B times h. But with the cylinder, pi r squared times h. Super simple, super easy. Okay? But there's that. A couple just tidbits here and there of like some things that you may not have remembered from before. Remember that the diameter goes through the entire circle, through the center as well. The radius only goes through halfway of the circle. So you're only looking for the radius and the height. That's all you need for this equation. So I already did the math here, right? If I know that my r, my radius is 2, and I know the height of my cylinder is 5, I can just plug that straight in to my equation here. So volume is approximately 62.83. I did round to the second decimal, centimeters cubed. Very easy. So I think now that you know what a prism looks like and how they are kind of more difficult, cylinders shouldn't be as hard. Go ahead and try these 2 cylinder problems. The first one you should have gotten is 2,111.15 inches cubed. And the next one you should have gotten is C. That is the closest answer. More specifically, it is going to be 1,017.88 centimeters cubed. Again, I did round to the second decimal place. But which one of these is closest? Obviously, 1018 is closer to than 1017, of course. Okay. Now, surface area is where it can get a little bit tricky. Like if you're looking at this blurb of text here, you can see a lot of different instances where I say the word surface area. There's a ton of them. Okay. But here are the Sparks notes, the keynotes of it. Lateral surface area is smaller than total surface area. Okay. Or even like going before them. There are two kinds of surface area. There's lateral and there's total. Lateral surface area is essentially just the areas of the faces, not including the bases. Okay, which sounds really, really kind of redundant, kind of sounds really difficult to hear, but it's all the faces except the bases. Okay, so for example, if I'm thinking of a prism, right, and I'm looking at the lateral surface area of a triangular prism, I'm not going to include the triangles, only the 3 rectangles that I have. That's all I want for lateral surface area. Whereas for total surface area, I want the 3 rectangles I get for my lateral surface area and my 2 bases. So I'm going to have more in my total surface area equation than in my lateral surface area equation. But I know a lot of us only really learn from doing rather than being just told exactly what to do. So let's go ahead and look at this really quickly. But we are, sorry, get a little ahead of myself. We're going to look at these different letters here, specifically looking at, say, this one, okay? Because our lateral surface area is the newest one here. Or rather, that has the more of the newer vocabulary here. We should recognize capital B and lowercase h. Capital B, of course, is our base area, and lowercase h is going to be our height of the prism or of the cylinder, depending on what it is. But capital S and capital P are new. Capital S is just the surface area letter, much like how capital V is the volume letter in the volume equation. Capital P, sorry, is the equivalent to capital B, but instead of area, it'll be about perimeter. Okay, so a quick reminder about perimeter here is that you add up all the sides if it's a straight edged figure. However, if it is a circle, you must use this equation right there. Otherwise, it's not going to work. And if you went ahead and tried to do these, you would just add 9 plus 4 plus 9 plus 4. You would get the 26 inches. And then for the circle, it would be 56.55. Right? Again, I think you all can figure that out pretty simply. And you can use the calculator with you as well. So you should be fine. But that is how you find the perimeter, right? Capital C is that circumference. Okay, that is the perimeter of a circle, essentially. But let's actually look at this specific problem. Okay, I have 2 problems that we're going to look at. We're going to look at this prism and we're going to look at a cylinder. Cylinder will take probably like less than a minute. It'll be really quick because the prism is here and it'll take a little bit more time. So, a couple things. Notice here that we don't have any direct measurements of our base here. It's the lowest part. It's the part that's going to sit on our table here. We don't have any measurements for it. But don't forget that the base has an equal, congruent other figure, other face, that is also a base. So since this value right here is 8 yards, this value right there is also 8 yards. Since this value is 4 yards, that value is also 4 yards. So do not get too confused whenever you see something like that. Okay, don't get too confused. And I've already done all the math here. Okay, so lateral surface area. We just need the perimeter of the base, which is easy enough, right? We're working with a rectangle. Opposite sides are equal to each other. So I have 8, 8, 4, and 4, and I'm going to get 24 yards. Well, 24 yards times my height of 3 gives me 72 yards. Notice that my capital P perimeter is not in squared units. Okay, capital P is in a length value, therefore it is not squared and it is not cubic. Okay, however, if I multiply my height times my perimeter, I will have that squared unit. Okay, again, this is my surface area that is lateral. Okay, my lateral surface area. Then my total surface area, I'm going to take what I found in my lateral to help me get my total surface area. Because if I look at my actual equation right there, I see I have pH. That comes directly from my lateral surface area. I'm only adding 2 times capital B. So I already know that I'm starting off with this 72, right? Exactly what I got for my lateral surface area. And then I'm going to find the components of my base. I know it's a rectangle. I'm going to multiply the length and the width. And I'm going to multiply times 2 because I have two bases. Cannot forget that I have two bases. So I have 2 for the two bases times the length times the width, adding to my 72 that I already had for my lateral surface area, and I get 136 yards squared. This is still squared, okay, because it's area, still squared. And that's about it. Cylinders, again, very similar, but you only need two things. You need a radius and you need a you need a height. That's all you need. So if I'm multiplying this correctly, my lateral surface area is 2 pi r times h, just like my equation says, right there, 2 pi r h. Then I'm going to take my lateral surface area, the same thing I found right there, and add it to 2 pi r. Well, 2 pi r squared. Pi r squared is my area of a circle. 2, again, is my two circle bases. So, very simply, 2 pi r here, times my height. That gives me 150.80 yards squared. Again, I did include this as a, or rather, I did round this to the second decimal place. And because I did round it to the second decimal place, that's why I included that 0 there. I actually rounded up. That's why I had that there. And then my total surface area, again, is I'm just taking that exact same thing I just found right here, same exact thing. Then I'm adding it to 2 pi r squared, and that'll approximate to 376.99 yards squared. Okay. One quick thing I wanted to add here, though, is you want to round at the end. So even though I rounded for the 150.80 here, I did not use 150.80 because I knew that there was other numbers attached to it. That's why I used the original rather than the abbreviated version, if you want to call that, or the rounded version. Okay. So just make sure you're doing that correctly. Then I would round at the very end. After I've added those two values together, I find out what it is. I round it at the end, blah, blah, blah. There we go. Okay. Then I want you to go ahead and try these two problems. But I want to leave you with one calculator tip that's going to help you. Okay. The calculator tip is initializing. We've talked about what initializing does and what it's useful for. So what we're going to do here is if I'm looking at my cylinder here, I see that my cylinder has a radius of 3. Well, I'm going to say that my radius r equals 3. Then that my height equals 3 as well. And because I can do that very nicely and easily, I can just plug in my lateral surface area equation as I need to. So capital L, let's just say for lateral, equals, well, it was 2 pi RH, so that's what I'm going to put. 2 pi R and H. And just to give you a little bit of a hint, it is 56.54, or rather 55 if I rounded it correctly. So 56.55 centimeters squared. And there is your equation. You can also set this up for your total surface area. So total equals, your lateral plus the 2 pi r squared, blah, 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 from there. Okay, go ahead and try from there. You should have gotten 226.19 centimeters cubed. And what you should notice here is that you can do the exact same thing with your lateral surface area, right? Take your perimeter times your height plus your 2 times your length times your width, go on from there. My recommendation for that specific way would be change to length and width. You will need a height value at some point, so h equals, it would be useful. So if I were to do this correctly, I see my length is 11, and then I see my width is 3. Luckily, it's already there. My height is 4.5. Then I know my perimeter, capital P, is equal to, well, 2 lengths plus 2 widths. I get 28. And my lateral surface area is equal to my capital P times my H. And notice how I do get specific values from there. Okay. So again, I gave you a little bit of a shortcut there. I already gave you that 126 feet squared is my lateral surface area. Go ahead and solve for your total surface area using the exact same method, right? So capital T equals PH plus your 2 times your length and your width, because that is your base and that is the area of your base. You should have gotten the value of 900 or not 900, 192 feet squared. Okay. Now, looking at the timing of this video, it's only about 30 minutes. And because, I yap a lot, I talk a lot, just a lot of things I got to talk about with math, right? But ideally, this should not take you more than 45 minutes to do in this class. If you are taking longer than 45 minutes to do this in class, you're getting well behind. There will be a Delta math assignment that you will have to complete that I have not made yet, but I will make it. You can be assured of that. So make sure that you are taking these notes down with fidelity and making sure that you are really trying to understand how to do surface area and volume, because you will see this in geometry. Okay, and you didn't see this in algebra up until right now. So you need to at least have seen this and be able to say, you know what, Mr. Loud did teach me that last year. It may have been at the very end, but at least I kind of know what I'm doing. I've seen this before, and I don't have to give my geometry teacher, whoever it is, a headache because, oh, my algebra teacher was a lousy person, which we all know I'm not. Kind of, but not really. Okay. If you have any questions, you can ask me on Wednesday whenever you see me next. But that's pretty much it for me. Again, ask me any questions if you need it, but I will see you all later. Goodbye.